Okay, welcome to Simplifying Expressions by Substituting Values in for the Variables. For question 1a, we have 3x, which means 3 times the value of x, and then we have plus 2y, which means 2 times the value of y. So for substitution, we're just going to replace the value of the variable, which in this case is x, with its given value. So x is equal to 1/2, according to what it's been defined as. So in brackets, we're going to put in a 1/2. And then we have plus 2, and then the y value is -2/3. Now I like to move my negative up with the numerator so I don't lose it in my calculation. All right, now I'm multiplying fractions. That 3 really is a rational number. It can be written as a fraction over 1. That's the easiest choice. With multiplying fractions, you're just going to multiply numerators or tops together and then multiply your denominators together. So 3 times 1 is 3, and then 1 times 2 on the bottom is a 2. Likewise, I have a 2 over 1 here, so I have my 2 times -2, or -4 on the top, and then on the bottom I have a 1 times 3, which is 3. Now I'm adding fractions. To be able to add fractions, I'm going to need to get a common denominator. So between 2 and 3, I can work with 6 as a common denominator. So I'm going to times that 2 by 3, which means I also need to times the top by 3 to keep it equivalent. And to change the 3 to a 6, I would need to times by 2, but I have to do the same thing to the top to keep it an equivalent fraction. All right, so at this point, 3 times 3 is a 9 over 6, plus I have -4 times 2, which is -8 over 6. And if I'm adding a negative, that really becomes a subtract. So 9 take away 8 would be 1, and the numerator or the denominator stays the same at 6. All right, try the next one. You can put me on pause and try it, and then you can check your solution after. I'm going to head with the solution here. Z has a value of -4 over 3, so it's a fraction, and it's going to end up getting squared. This line between the two means divide. So I'm going to change this to a divide symbol of a line with the 2 dots, just because with fractions it looks weird to have a fraction over a fraction. And then I have, and I'm going to keep, whoops, that was not supposed to happen. I'm going to keep this as xy. So x times y, my x is a 1/2. So x times the y is on the bottom here, times y, which is -2/3. All right, so I'm going to evaluate the exponent. -4/3 times -4/3 would be a positive. 4 times 4 is 16, 3 times 3 is a 9. And then we have divide by, and then I'm going to evaluate this bracket. So a 1/2 times a -2/3. On the top, a 1 times -2 would be -2. And on the bottom, we have a 2 times a 3, which is 6. Now, when we're dividing fractions, we invert and multiply. So the first fraction stays the same, and then it becomes a times, and then we're going to multiply by the reciprocal here. So the reciprocal, I could actually reduce that. I'm going to have 6 over -2. Normally, I'd keep the negative at the top, but 6 divided by -2 actually is -3. So I'm going to switch that. 16 over 9 times -3 over 1. And that's going to equal, at this point I could actually reduce. 3 goes into itself once, and 3 goes into 9 3 times. So on the top I would have 16 times 1, which is 16, and on the bottom I have 3 times 1, which is 3, and overall I should have a negative with that, because there's one negative being multiplied and divided. So that should be your answer, -16 over 3. We're going to leave these as improper fractions when they come up. All right, simplifying. Number 2, simplify the following expressions. This is where we need to collect our like terms, and like terms have the same variable part. So if I look at this first part, I have a 2x squared, and I'm looking for another x squared. So here I have a plus 4x squared. So I always take the sign in front of my term. So 2x squared plus 4x squared, that's going to equal 6x squared. All right, next term, I'm going to take a look at the x terms. I've got a -3x or a -3x, and I have a -5x. So again, the sign in front goes with it. I'm down 3 x's, and then I go down another 5 x's. Altogether, I'm down 8 x's. All right, and then we have constant terms here. I have a plus 6 and I have a minus 8. So I have 6, but then I take 8 away from that. I'll be at minus 2. So overall, I'm just going to rewrite the answer in a plain color here of blue. We would have 6x squared minus 8x minus 2, writing that in descending powers of x. All right, the next one, simplifying our expressions, I have a binomial, take away a binomial, add a binomial. So if I put those things together, this first binomial, 4x squared minus 7x, cannot be simplified, so I'm just going to rewrite it without the brackets. I'm not multiplying anything. I don't need those brackets anymore. I'm done with that. But then I want to take away x squared and a plus 5. If I take away an x squared, I'm going to have take away x squared, and then I want to take away plus 5x, which really is the same as subtracting 5x. So a couple ways to think of that. You're just switching the signs of everything inside the bracket when you have that subtract there, or put a 1 with that and think of multiplying -1 through that bracket. All right, and then we're adding an 8x, and we're adding a minus 6x. So if we're adding a minus 6x, it's the same thing as just subtracting 6x. All right, and then we want to collect like terms again. So my x squared terms, I've got 4x squareds. I'm going to minus an x squared, so I'm at 3x squared. But then I'm going to add 8x squared. That will give me 11x squareds. I have a minus 7x, so I'm already down 7x's, and then I go down another 5x's. That's down 12x's, and then I'm going to go down another 6x's. I'm at down 18x. And then I'm out of terms. That's it. So my answer is just my 11x squared. You don't have to write it again. It's just because I used 2 colors there, and I like to be consistent with my color and just make it look like I have a nice color there. Simple color. So hopefully that makes sense with that one. I'm going to stop here and then do the next questions after that.